Hello everyone, welcome back to the 5 Minute Tech channel. Today we will be talking all about span, exploring a new .NET mainstay and also exploring a way of writing high performance C# code using span struct. So here I have a simple project which has just one file, which is the program CS base file, and here I have a simple int array which will have its sizes passed as parameter 100, 1000 and 10,000 to measure the performance. The base setup which does is to add the value to the array, and then the baseline, which is I'm using a benchmark to understand the performance behavior. So baseline, wherein I will be using a skip, take and dot to array original setup, then an array copy which does a similar operation, and then we will be using a span which is array dot as span, and then we are doing the slice operation of the span. So all this will be checked through a performance parameters of benchmark. So let me run this and we'll analyze the performance. So here now benchmark is collecting its output about the time it is taking for execution of different methods, and here we have the result. Let's explore the result now. So as you see here, the original method which we had here, the original method took 134 nanosecond for 100, and similarly for 1000 and 10,000 it is much more. Array copy also is taking much more nanoseconds. So but the span, which is not even creating any memory allocation, as you see here, there is no memory allocation generated by the span method which we are implementing, and it is the fastest among the three. We'll jump on to the another implementation for the string manipulation. Now for the string manipulation example, I have a get last name method, which what it does is tries to take the last name and using a substring and using the last name with a span. So there is a simple method which takes the last space index, I pass the full name. Similarly with the read-only span, I pass the full name, I take to the slice of it, whereas with the substring I do a dot substring with the particular index which I'm trying to use. The base class, the class which is calling that, is creating an object of it. I pass the full name and I get the last name out of these three. I get the last name out of this string using a substring and with a span, and we'll check the performance of it with using the benchmark. So let's run it. So I have triggered the build for it, and we will be subsequently getting the benchmark result out of it. So here we have got the output from the benchmark result. Remember, we have done with a substring, we have done with a last name with the span. So let's go back to the result. If you see the last name with a span, it takes 2.98 nanoseconds. It does not create any memory allocation, and also it's the fastest among the three as we have ranked it. And the guest last name using a substring takes more time, and a simple last name, it takes even more time. So now let's understand how this span works and how is it so efficient. So let's consider a programming scenario wherein we are exposing a specialized sort routine where you're trying to do a specific to operate in place of on the data in memory, and you would like to expose a method that takes an array and provide an implementation. So the input is array and it provides a specific sorting, and that operates over a type T array. So it's array of a particular type. That's great when your method caller has an array and wants the whole array sorted. But what if your caller only wants part of it sorted, not the entire array? You would probably then also expose an overload that takes an offset and account, like from position to which position you want to do it. But what if you wanted to support a data in a memory that wasn't in the array but instead came from a native code, so the source is different of the data, and it lived in a stack and you want to have a pointer and a length? How would you write your sort method in that case that operated on such an arbitrary region of memory different place where it is stored, and yet worked equally well with full arrays or with subset of arrays, and that also worked equally well with managed array and unmanaged pointers. So at different data sets you have, and you have to make the sorting operation, the way you get the result out of that array from different sources and manipulate to give a result output. So that is one programming scenario. Consider another programming scenario wherein you are implementing an operation over system.string. So system.string is immutable. So when you work with string, you tend to make number of copies of it and all those things. So such as specialized passing method, you're trying to parse a string. You'd like to expose a method that takes a string and provide an implementation that operates on that string. But what if you wanted to support operating over a subset of that string? Again, you're trying to take a part of that string, and the strings.substring could be used to carve out just the piece that's interesting to them. But what's the relative expensive operation, as I mentioned, involving your string allocation and memory copy? You could, as mentioned in the array example, take an offset and count, but again, what if the caller doesn't want the string but instead a character array? Or what if the caller, and how would you write your parsing method in a way that didn't force the caller to do any allocation or copies? So no memory allocation required, no copies are required, and yet worked equally well with inputs of type string, character array and char pointer. So all these scenarios are there to make you explain the use case wherein the span fits pretty well. So let's jump into what is span. Span is a system.span of t, type t, is a new value type. New in the sense it was released with 2.1 and it is been there for it is. So system.span of t is a new value type at the heart of .NET. It enables representation of contiguous regions of arbitrary memory regardless of whether that memory is associated with a managed object, is provided by native code via interop, or is on the stack. So wherever that is the present, it could be accessed and taken as a copy, and can be output can be generated out of reading that particular data, and it does so while still providing safe access with performance characteristics like that of an array. So I think that's the gist of span. We'll explain more in detail. This is a little more verbose, but you need to just understand that a span is your struct, which is a value type, and it accesses memory as a pointer to it, and it reads that and it helps you generate the result out of that. So the struct basic definition, basic structure of struct is private read-only ref pointer and private read-only in the length of whatever length it is. Again, span are only a view into underlying memory and aren't a way to instantiate a block of memory. Okay, so it is just a pointer to the underlying memory. Span T provides read-write access to the memory, and read-only span provides read-only access to the memory. Therefore, creating multiple spans on the same array creates multiple views of the same memory, as I have illustrated here. So it has t star pointer, int length, span of t, and the length will be 4 and it will be to a string, whichever you're declaring. So moving on, we can use span with heap, a managed object, example array and string, stack via stack alloc, native and unmanaged code, PA/invoke. It is very useful because we can simply slice an existing chunk of memory and manage it. We don't have to copy it and allocate new memory on the heap or anywhere else. List of the types that can be we can convert to span of t from array, pointer, stack alloc, and int pointer. We can convert directly into span of t. Now with read-only span t, we can convert all above and string as well. Thank you for watching this video. If you like the video, do press like and subscribe to the 5-Minute Tech channel.